Hi everyone, I'm the Nature Guy and I'm here at Camp Asabal in the Nature Center. We're down in the basement of the Nature Center, which is our lab, where we can do some neat experiments and work with microscopes. Well, today I want to talk to you about our noses. So I don't have any props with me, I'm wearing my prop. Now, noses are really interesting. We know that the sense of smell is very good in humans. Now, dogs have an even better sense of smell. But in our noses are 400 different types of receptors that sense 400 different chemicals in the air. And then our brain takes all that information and then decides, oh, what is it that we smell? So when you smell an apple, for example, take a whiff, it activates all those, well, actually little particles of the apple float through the air into your nose and stick to the receptors in your nose. And then those receptors send signals to the brain, and then the brain says, oh, you got signals from this one and not that one and this one, and oh, it must be an apple. So what does that mean when you're smelling some stinky cows down the road? Little pieces are floating over and sticking to the inside of your nose. Well, enough of that. So our nose is really sensitive, and it's got lots of detectors, and that's cool. But something new has been discovered about our noses that we didn't know of, even though it's right here in front of our noses. We didn't know this until a couple of years ago. Researchers at Stanford University discovered that the two sides of our noses don't work exactly the same way. Now that shouldn't be surprising because our two eyes are different. You can do a very simple experiment. Stare at something off in the horizon, keep your eyes open, and then put one hand over, and then move the other hand over, and the picture changes a bit because our two eyes are looking at the world a slightly different way. And by the brain taking that information, it can help us detect depth of field and focus and so forth. And our two ears are a little lopsided. This one's a little lower on my head than this one. You see, it's not quite right. And so we detect sound from two different angles, and that helps us to figure out where the sound is coming from. So we got two nostrils. There must be a reason. And it turns out that the two sides of our nose don't work the same. They don't smell things the same way. And so you can kind of do this experiment. Some things work better than others. I've got a bottle here of vanilla. Don't spill it, but I can open it up, and if I then just sniff with one side compared to the other side, this side smells sweeter than this side. It's quite similar, but subtly different. And if you really want to do this experiment in kind of a neat way, you can take an orange, okay? I just cut the orange in half and it's all juicy and smells like an orange. Smells like a ripe orange. And then I've got some mints, a little chopped up mints, okay? So, and that smells quite a bit different. Oh, they're not coming out of the bag, okay? So, yeah, it smells like mint. And so I'm going to sprinkle some of the mint on top, not too much to overpower, but I got a little bit of sprinkles of mint chocolate on top of the orange. And now I'm going to do the same kind of an experiment. I'll go. I can smell the mint better with this side, and I can smell the orange better on this side. And that's both of them together. So why does our nose do that? It's really cool. Well, it turns out that in our noses, the way the muscles and blood vessels flow through the nose, one side brings in air faster than the other. We call this a high flow and a low flow nostril, okay? And so the high flow, lots of air goes in real quick, and that detects the chemicals in the air that can bind to the receptors very fast. But some chemicals don't bind really fast to those receptors, and it takes a while. So we have one nostril that works as a slow flow nostril. And so the air goes in slower and gives time for the pieces to actually bind to the receptor so that your brain gets the most information possible. But you know what's really cool? The high flow and the low flow sides of your nose switch every few hours. So 4 or 5 hours from now, it'll be opposite. We have no idea why that is. Maybe to keep everything fresh so it doesn't get stale in there. I don't know. But our noses that we've been looking at in the mirror for our whole lifetimes are doing incredible things we didn't even know. You know, that kind of reminds me of something like in this Bible. It's right in front of our noses sometimes, but if we don't spend time studying it and seeing what it really has to say about me and my life today, then we're going to miss something. Just like we've been missing all this cool stuff that's going on in our nose until just a couple of years ago when scientists took a closer look. We need to take a close look at God's Word and see what He has to say for us. That's it for today. Thanks for listening, and we'll see you next time.